Okay, we're looking at Cocker Spaniel dogs and talking about two of their traits, which makes this a dihybrid, probably a cross. They haven't talked about crossing yet, but I figure like it's bound to come up. They say black coat color is dominant to white coat color, which gets the little b, so let's get a legend rolling. Big B gives you a black furred dog, and little b gives you a white furred dog. And solid coat, big S. I'm going to use great big S's for capitals and itty bitty S's for lowercase. S is solid, as in all one color, and little s means spots. Pattern arrangement is on a different chromosome than the one for color and segregates independently. Yeah, we assume that anyway. This is independent assortment, and it tells us that the B trait and the S trait are not connected or are not linked, which if we didn't assume that, we'd be in trouble, and none of this Punnett square stuff would work properly. So good that they pointed it out, but we would have had to assume it anyway. Now, this one is not going to be a Punnett square. This is the sort of problem where they give you all the details. They don't ask about probabilities for the offspring. They actually tell you what the offspring are. And so we're going to get kind of a family tree here. And from that, they're going to ask us some questions about the parents. So we have, this is the dad who has black fur and a solid pattern. And he mates with 3 different females, and each of them has a litter, and they're going to tell us about the puppies and ask us to work backwards. So, dad is black coat, which means, well, that's a problem because they could be big B, big B, or they could be big B, little b. So, I'm going to put dad over here. Dad is going to be big B, don't know, and then capital S, don't know. If you have black fur color, you have to have a big B, but we don't know what the second thing is. And if you have solid coat, you must have a big S, and we don't know what the second thing is. For now, that's all we've got on dad. Now, we have mom A, who is white. That means she's little b, little b. That's nice. It's good to see this because we know her genotype instantly. And her coat is solid, which means she is big S, don't know. She could be big S, or big S, little s, and for the moment we can't tell. Probably her puppies will tell us something about that. Then we have mom B, who is black and solid. She's just like dad. We don't know much about her genotype, or we know big B and big S, but these other two are blanks to be filled in. She could be homozygous for B and for S, or she could be heterozygous for either one. More about that in a minute. Mom C is white and spotted. Oh, that's lovely. To be a white Cocker Spaniel, you have to be a little b, little b. And to be spotted, you have to be little s, little s. So recessive traits are nice because they tell you exactly what the genotype has to be. We've got this one completely figured out before we even look at pups. So, what do we know about, speaking of puppies, let's get them in here. Mom A produced 4 puppies, 2 black and solid, black and solid. Well, this is not great because these are just like Dad's. We don't know anything about their genotype really, and it's hard to read this back. And well, there's some blanks here that we could fill in, but we'll get to that in a second. And 2 white solid. Some of her puppies are white, which means little b, and solid means big S blank. Okay, we'll come back to that in a bit. Mom B produces 1 puppy who is white and spotted. Little b, little b, little s, little s. This is a good puppy. This tells us a lot because their recessive traits are showing. That means we know exactly what their genotype is. Very helpful. And from Mom C, we got a white and solid. White is little b. Solid means big S and don't know. White and spotted means little b, little s, little s. Black solid means big B, don't know. And solid is big S, don't know. And black spotted would be big B, don't know, little s for the spots. All right, so we are not required to fill in everything we know about the puppies, although I might do that just for grins, but we are supposed to find out everything we possibly can about the parents. So what do you see here? As a rule of thumb with these, you remember when we were doing puppies, we found that the ones showing recessive traits were the most helpful. That's true in general, and these are generally the ones you should focus on first. If you see big B and big S, you're like, put that off until the end. These usually are where you get your best information, because look at this. This puppy has a little b and another little b. Where did those come from? One of them had to come from dad, and one of them had to come from mom, which tells us mom must have had a little b. She produced an egg with that, and dad produces sperm cells with little b's, so he must have that also. What we knew about mom and dad was that they had a big B, but clearly this pup didn't get either one of those, and that's why they came out with the double recessives. The only way this can happen is if you got one of these from each of your parents. And the same thing comes up with the spots. This spot trait means this puppy got a little s from mom and a little s from dad, which means they must have those things in the genotype. Mom's heterozygous, dad's also heterozygous. So, excellent. This one puppy gave us full information about mom B and about dad. Fantastic. We already know everything about mom C just from looking at her. She didn't even need to have this to have kids for us to deduce this. She's a white puppy, so she's a white Cocker Spaniel, so we know she's little b, and we know she has spots, so she's little s. That's all good. This is the only blank left. How did this happen? Can we nail this one down even? This puppy was big S. The trouble is that could have come from either parent. And she had this one, which, again, big S could have come from either parent. Hard to tell with this one. We may not be able to fill this in with full certainty. Now, having said that, I'm going to say we don't know for sure what is in this space. I'm going to use kind of a weak argument, and I want you to notice it's a weak argument, but I am going to make it because you will hear this sometimes when people analyze these things. They will say, if this mom was big S, little s, and you cross these parents, you would expect to get 3/4 of their offspring would be solid. They'd get a big S from one parent or the other. 1/4 of them would be spotted. They'd get little s from and end up recessive. In other words, if mom had a little s, you'd expect to occasionally get a little s puppy. That's true. The trouble is, they've only had 2 puppies here, and so it would be pretty easy for this to not happen. The fact that we haven't seen a little s doesn't tell us very much about mom's genotype, and so you shouldn't look at this and say, well, they've had 100% solid puppies, therefore she must be big S, big S. That's not a good argument to make when they've only had 2. So if you're thinking about putting a big S in this space, I would say you should not at this case. Now, let me change the numbers a little bit. What if they had 20 puppies and every one of them was coming out solid? They're all big S blank, big S blank, big S blank, big S blank. If there were 20 of them, you'd at that point you'd say, well, by now we should have had a couple of little s's. They should be happening 1/4 of the time, and we've had 20 or 101 puppies or however many, and there's no little s's showing up. In that case, you would be justified in saying, I suspect that this mom is big S, big S. She's true breeding solid, and that's why all of her puppies are solid. But it's premature to say that when there have only been two. Two could just be luck. If you get into 10 or 20 or 50, then yes, okay. Now it's fair to say that mom is probably homozygous, but from just two, I do not think that is safe to say. We don't have this evidence down here, and I think we're stuck leaving this as a blank. She could be big S, big S. That would account for these puppies, but she could also be big S, little s, and so far they've just lucked out and gotten solid pups both times. So unfortunately, although the question doesn't really mention that, doesn't say indicate if possible or anything like that, we run into a wall here where we're like, we can't be sure about the genotype of this mom. There is not enough evidence here yet, and I'm not going to give you a number. I'm just going to say if you have, certainly if you have less than four puppies, you shouldn't be expecting to see a little s yet. If you have way more than four, then okay. Maybe mom is homozygous, maybe she's big S, but for what we have as information, I would just give that as a blank or a question mark.